Ever watched an AI model make one small spatial mistake and watch it completely derail its entire answer? That's error propagation in chain-of-thought reasoning. When models autoregressively build each step on the last, a tiny early flaw snowballs into total failure. New research solves this with stepwise value gating. Instead of committing to a single trajectory, the model generates a branching reasoning tree. Then, a lightweight discriminative gating model evaluates every intermediate step in real time. Here's the technical core. It uses Monte Carlo rollouts to estimate the expected value of future steps, then applies what researchers call support contraction. Any path dropping below a learned quality threshold gets instantly pruned. But it's not a hard binary filter. The system dynamically rescales the probability mass of surviving paths based on the intermediate states they traverse. This effectively reshapes the model's output distribution, concentrating attention on high-value trajectories while quietly redistributing weight away from drifting branches. This creates a hierarchical two-gate system. An early step advantage gate intercepts logical missteps before they contaminate subsequent generation. A final trajectory advantage gate then compares all surviving complete paths to select the optimal answer. Crucially, the gating model runs in a single forward pass. Contrast this with tree of thought or self-consistency, which require generating dozens of full chains and running heavy voting models. This framework is plug-and-play, trained on over 100,000 curated reasoning trees, and requires zero fine-tuning of the base transformer. Across 3D spatial datasets, it delivers double-digit accuracy gains while drastically reducing inference overhead. The breakthrough isn't just better scene understanding. It's a paradigm shift from brute force generation to value-driven selection. By filtering reasoning paths step by step, we get systems that actively optimize their own thought process. As AI tackles increasingly complex tasks, this kind of real-time, lightweight evaluation is exactly how we build reliable, self-correcting intelligence.